Take everything out of your house. Not the furniture, not the appliances, not the decorations. Everything. The walls, the roof, the foundation, the plumbing and electrical systems, and the insulation you've never seen but trust is doing something useful inside those walls. The door that locks, the windows that let in light without letting in weather. Take all of it away and replace it with what you actually have. Your body, your knowledge, and whatever you can make or find in the landscape around you. Now it is starting to rain. This is the situation that ancient humans navigated every single day of their lives across hundreds of thousands of years. Not as an emergency, not as a survival challenge on a television show with a camera crew 20 meters away and a medical team on standby, but as the ordinary baseline of existence. Rain happened. Cold happened. Wind happened. Night happened. And ancient humans dealt with all of it without a single wall of manufactured building material, without a single engineered structural component, without anything that would show up on a modern architectural drawing. And here is what most people have never seriously considered. They were fine. Not just surviving level fine, actually fine. Warm enough, dry enough, safe enough, sleeping well enough to function at the cognitive and physical level that the extraordinary challenges of ancient life required. The evidence from the archaeological record, from the physiology of human environmental tolerance, and from the detailed studies of traditional communities that maintained ancient-style habitation patterns into the modern era all point to the same conclusion. Ancient humans living without houses were not suffering the miserable, exposed, constantly threatened existence that modern intuition assumes. They had solutions. Sophisticated, carefully developed, extensively refined solutions to the problem of existing in the natural world without permanent manufactured shelter. And those solutions are the subject of today's video. Let's start with a number that puts everything in proper context. Ancient hunter-gatherer communities spent approximately 60 to 70% of the year in conditions of reasonable resource availability. Not flush with abundance, not comfortable in any modern sense, but in conditions where the immediate physical environment was not actively trying to kill them. This matters because the popular image of ancient life without houses tends to be calibrated to worst-case scenarios. The blizzard, the downpour, the freezing night. As if these were the average condition rather than the episodic challenge. For most ancient humans in most seasons, the primary shelter requirement was not protection from extreme conditions, but simply a reliable, reasonably comfortable place to sleep, prepare food, and conduct the social life of the community. That requirement is significantly easier to meet than the extreme condition version, and ancient humans met it with a range of solutions that were adapted to specific environments, specific seasons, and specific resource situations with a sophistication that the crude "they lived in caves" narrative completely obscures. Let's talk about wind protection first, because it is the most universally important environmental factor in shelter design and the one that ancient humans addressed most immediately. Wind is the primary driver of convective heat loss, the mechanism by which the human body loses heat to moving air that is cooler than skin temperature. A still day at 5 degrees Celsius is uncomfortable but manageable for an adequately clothed person. A windy day at the same temperature with a 30-kilometer-per-hour wind produces wind chill conditions that are physiologically equivalent to a much colder, still air temperature. The difference between adequate warmth and dangerous cold in many ancient weather conditions was not the temperature, but the wind. The most immediate and effective wind protection available in any natural landscape is terrain. Hills, ridges, rock outcrops, dense vegetation, anything that deflects, reduces, or breaks the wind on the leeward side creates a microclimate that is dramatically warmer and more livable than the exposed ambient conditions. Ancient campsite selection incorporated terrain-based wind protection as a primary criterion, and the consistent pattern of ancient habitation sites in sheltered locations. South-facing slopes, leeward sides of ridges, positions sheltered by rock outcrops, forest edges that block prevailing winds, is visible in the archaeological record. The specific knowledge of local wind patterns, which directions the prevailing winds came from in different seasons, which terrain features provided the best protection from each wind direction, which locations combined good wind protection with adequate visibility and fire safety, was part of the accumulated landscape knowledge that ancient communities maintained and transmitted. A group of ancient humans choosing a campsite was not choosing randomly from available options. They were selecting from a cognitive map of their territory that included specific information about the shelter qualities of different locations under different conditions. Let's talk about the structures ancient humans actually built, because even without permanent houses, ancient humans were constructing shelters, and those constructions were considerably more diverse and more sophisticated than most people imagine. We have established in other discussions the existence of mammoth bone houses in the Ukrainian steppe, dating to approximately 15,000 to 25,000 years ago. We have established the 200,000-year-old grass bedding at Border Cave. These specific examples are the most dramatically documented cases of ancient constructed shelter, but they represent extremes of the distribution, the most elaborate and most archaeologically visible instances of a general practice that almost certainly operated in some form across the full span of ancient human existence. The most common ancient shelter form in forested environments was almost certainly the lean-to, one of the simplest structural concepts available, and one that requires minimal materials and minimal construction time. A lean-to is simply a sloping surface that deflects wind and rain on one side, with an open front toward the fire and an elevated back that sheds precipitation. The structural requirements are modest. A horizontal ridgepole supported by two uprights with angled cross members carrying a covering of leaves, bark, grass, or hide from the ridge to the ground. Construction time with adequate materials, 30 to 60 minutes. Weatherproofing quality in moderate conditions, entirely adequate. The dome structure, a framework of bent poles anchored in the ground and lashed together at the top, covered with hides, grass, or bark, is found in essentially every traditional culture worldwide that has maintained ancient-style habitation patterns. The specific materials vary by region. Hide-covered domes in open grassland environments, bark-covered domes in birch forest environments, grass-covered domes in tropical savanna environments. The structural principle is universal and produces a structure that is both thermally efficient. The dome shape minimizes surface area relative to enclosed volume, reducing heat loss, and wind-resistant. The curved surface deflects wind loads rather than resisting them directly. Let's talk about the thermal physics of ancient shelter, because understanding the physics is what allows you to appreciate how effectively ancient constructions worked with the materials available. A shelter does not need to be made of thermally insulating materials to be warm. It needs to create a bounded space in which the heat generated by the bodies inside and by a fire is trapped and accumulated rather than dissipated by convection to the outside air. The thermal barrier provided by any physical enclosure, even one made of leaves or grass, is substantially better than no enclosure at all, simply because it reduces the air movement that drives convective heat loss. A group of 20 people generates significant metabolic heat. Each adult human at rest produces approximately 80 watts of thermal energy, which across 20 bodies amounts to 1,600 watts of continuous heat production, roughly equivalent to 16 conventional light bulbs burning continuously. In an enclosed space, this metabolic heat accumulates. In a well-sealed enclosed space with a modest fire, the interior temperature can be maintained at comfortable sleeping temperatures even when outside temperatures are significantly below freezing. The specific insulation value of ancient shelter materials is not trivial. A thick layer of dry grass has a thermal resistance comparable to fiberglass insulation of similar thickness. A layered pile of dry leaves is an effective insulator. The hide coverings of ancient structures, while not as thermally efficient as modern building insulation, provided meaningful thermal resistance when combined with the metabolic heat of the occupants and the heat of a fire. Ancient builders who had survived multiple winters in specific locations had direct empirical feedback on what shelter constructions worked and what didn't. The survivors, the communities that successfully managed the thermal challenge of cold winters without modern building materials, were the ones whose shelter construction knowledge was adequate. The knowledge was validated continuously by the most demanding possible test: whether the people inside survived. Let's talk about the cave dimension, because it is simultaneously the most discussed and most misunderstood aspect of ancient shelter. Caves were used extensively. For hundreds of thousands of years, ancient human communities occupied caves where they were available, where their location relative to food resources was convenient, and where their specific characteristics made them suitable for habitation. The deep archaeological record of cave sites across Europe, Africa, Asia, and the Americas documents continuous and repeated occupation across enormous time spans. But caves were not the default shelter for most ancient humans most of the time. They were the premium option when available. And availability was limited by geology in ways that meant large portions of the landscapes ancient humans inhabited had essentially no suitable caves. The cave as default narrative collapses under the simple observation that most of the Earth's surface where ancient humans lived is not karstic limestone terrain capable of producing the cave systems that ancient habitation required. The caves that were available were also not ready to occupy shelters in the way that the popular image suggests. A natural cave is damp, cold, unlit beyond the entrance zone. Potentially occupied by bears or hyenas with strong opinions about cohabitation, and structurally unarticulated in ways that required significant modification to make habitable. Ancient cave occupation involved the same kinds of interior modification: fire positioning, sleeping area preparation, wind control at the entrance, pest management, that any other ancient shelter construction required. The cave was raw material for a habitation, not a finished product. What caves uniquely provided was permanence and structural protection. A cave entrance blocked by hides, with a fire positioned to warm the interior and deter predators, and with the interior floor prepared with grass bedding and organized into functional zones. That was a genuinely excellent habitation in cold climate environments. The communities that had access to such locations and could maintain them were in a significantly better shelter situation than those working only with constructed structures. But they were a minority of ancient communities, not the universal standard. Let's talk about mobility and shelter, because the relationship between mobile lifestyle and shelter construction is one of the most interesting aspects of ancient habitation strategy. Mobile communities face a specific constraint that permanently settled communities do not. Everything they have must be transported. The carry weight of an adult ancient human, already managing their own tools, food, and clothing, sets a practical upper limit on how much shelter material can move with the group. This constraint had a specific effect on ancient shelter technology. It drove the development of light, packable, rapidly deployable construction systems that prioritized fast construction and deconstruction over maximum comfort. The solution that multiple independent ancient and traditional cultures converged on is the hide frame structure. A set of lightweight structural poles that can be carried by the group, combined with prepared hides that serve as both clothing and shelter covering, producing a structure that can be fully erected in under an hour and fully dismantled in under 30 minutes. The poles are the primary weight burden, but they can be distributed across multiple carriers or in environments where suitable poles can be cut from local materials, left behind and replaced at each new campsite. In environments where suitable natural materials were reliably available at campsites, where grass, leaves, or bark could be collected for shelter construction at each new location. Ancient mobile groups could leave their shelter materials behind entirely when moving and rebuild from scratch at each new site. The knowledge of how to construct adequate shelter from available local materials in under an hour is the portable asset, not the materials themselves. This construction from scratch capability required specific knowledge that was maintained and transmitted within communities. Knowledge of which local plant materials made adequate shelter coverings, how thick a grass or leaf layer needed to be for weather protection, how to anchor structural elements in different soil types, how to position a structure relative to prevailing wind direction. This knowledge was the shelter technology, portable in the minds of the people who carried it. Let's talk about fire as a shelter component, because in the ancient habitation system, fire and physical shelter were not separate technologies. They were integrated elements of a unified thermal management system. A shelter without fire is a windbreak and rain deflector. A shelter with a fire is a genuinely warm space that can maintain adequate temperatures for comfort and sleep across a wide range of outside conditions. The fire inside an ancient shelter was not a separate item. It was the heating system that made the shelter thermally functional. The positioning of the fire within the shelter or immediately adjacent to it was a specific engineering decision with significant thermal implications. A fire positioned at the open end of a lean-to, between the shelter and the occupants, directed radiant heat toward the sleeping area and the fire's smoke away from it, while the elevated back of the lean-to reflected and retained heat in the sleeping zone. A central fire in a dome structure distributed heat radially to all points of the interior and used the smoke exit hole at the apex to manage smoke without losing excessive heat. The management of fire size and fuel type through the night was a continuous thermal optimization. A large, hot fire provided maximum warmth but burned through fuel rapidly and required more frequent attention. A smaller, sustained fire on denser fuel burned longer with less attention but produced less immediate heat. Ancient fire management at night, the banked fire that reduced oxygen access to preserve coals through the coldest hours, the strategic fuel selection that balanced heat output against fuel consumption across a long night, was a skilled practice that significantly extended the effective warming capability of available fuel supplies. Let's talk about the social dimension of ancient habitation, because the shelter problem in the ancient world was fundamentally a social problem as much as a physical one. 20 people in an enclosed space generate significantly more heat than one person in the same space. They also provide the distributed vigilance, the mutual care for fire management, and the collective knowledge of construction techniques that make the whole habitation system more effective than any individual effort could achieve. The social architecture of ancient sleeping arrangements, who slept where, in what proximity to whom, under what shared thermal arrangement, was not incidental to the shelter system. It was part of it. Shared body heat is a genuine and significant contribution to thermal management in cold environments, and the close physical proximity of ancient communal sleeping, multiple bodies in physical contact or near contact under shared coverings, produced a microclimate within the sleeping group that was substantially warmer than the ambient interior of the shelter. The communal fire watch, the distributed overnight monitoring of the fire and the environment that the natural sleep stage variation across a group provided, was part of the shelter system's thermal management. Someone was always likely to be in a light enough sleep stage to notice when the fire needed attention, or to detect the specific change in ambient temperature that signaled the fire had dropped too low. The group was its own feedback system for shelter performance. Let's address the psychological dimension, because the experience of living without a permanent house is not only a physical challenge but a psychological one, and ancient humans navigated it with resources that deserve recognition. The concept of home, the specific psychological sense of safety, belonging, and orientation that a permanent dwelling provides in modern life, is not entirely absent from ancient life without permanent houses. It is expressed differently. Home for ancient humans was not a specific building, but a specific community, a specific landscape, and a specific set of relationships with both. The territory that an ancient community knew intimately, the specific water sources, the specific shelter locations, the specific seasonal camps they returned to year after year, was home in a functional sense. The familiarity of the landscape, the knowledge of its specific shelter qualities in different weather conditions, the relationship with specific places that had been camped in by the same community across generations, all of this provided the psychological orientation that modern people derive from a permanent address. The return to the same seasonal campsite after months away, the specific location that the community had occupied last summer or last winter or for many years before, was a return to something that functioned as home even without any permanent structure marking the location. The specific spot was familiar, the views were familiar, the sounds and smells were familiar, and the preparation of the camp, the clearing of the space, the construction of the shelter, the establishment of the fire, was not the imposition of an unfamiliar task, but the recreation of a known and valued experience. Here is the picture that emerges when all of these pieces are assembled. Ancient humans living without houses were not experiencing a deficient version of modern housed life. They were living a fully developed, carefully optimized, functionally adequate version of life that had been refined across hundreds of thousands of years of continuous human occupation of the natural world. They had terrain-based wind protection identified through intimate landscape knowledge. They had constructed shelters adapted to specific environments and seasonal conditions, ranging from rapid lean-tos to elaborate hide-frame structures to the occasional premium option of a suitable cave. They had fire management systems that integrated with their physical shelters to produce thermally adequate interior environments. They had communal sleeping arrangements that added body heat and distributed vigilance to the thermal management system. They had the knowledge, portable in human minds rather than embodied in fixed buildings, to reproduce adequate shelter in any location within their known territory from materials available there. The rain that started at the beginning of this script is still falling. But you, if you had the knowledge that ancient humans had, the community they had, the fire management skills they had, and the terrain they knew, are dry. You are warm enough. You are in a shelter that is not impressive by any modern architectural standard, and that will leave no archaeological trace that any future researcher will find. But that is doing exactly what a shelter needs to do, making the inside different enough from the outside that the body's inside can rest, recover, and prepare for tomorrow. Ancient humans lived without houses the way fish live without bicycles. Not because they were deprived of something they needed, but because what they had was already the right solution for the problem they were actually solving. The houses came later. The ingenuity that produced them, the systematic problem solving, the knowledge accumulation, the adaptive engineering, was ancient all along.